Hi everyone, it's Dr. Bianchi, and in this video, I'm going to be demonstrating the t-statistics that we're going to be running for the statistical analysis project that is a mandatory assignment in order to pass the course. So I'm sharing my screen with you right now, and you'll see the instructions for the statistics project. Okay, assignments 1 and 2 are very straightforward. You're simply constructing different tables, different graphs, and in this case, calculating central tendency and variance, and just kind of copying and pasting those results into your Word document. So there really isn't much more to expand on there because these are descriptive statistics and they do a good job of summarizing and organizing the data for us. Our first inferential test is the one sample t-test. So in the data set, there's a variable called SF36. It's also known as the health score. It's a famous measure of mental and physical functioning, and higher scores on the SF36 health survey reflect better health, okay, and lower scores reflect worse health. We know that healthy populations have a mean score of 50 on this health survey. We want to determine whether the sample in our data is significantly less healthy than 50, okay, whether the mean score on the SF36 is significantly lower than 50. Maybe it is, maybe it isn't. That's why we're going to run the t-test. Okay, we're going to run the test. For the write-up of the assignment, please write out the results of the test in standard format, okay, just like we've been doing in class. And then you're going to be giving us a few sentences in just basic human language about what the finding was. Okay, let's go ahead and we're going to see our data set now. Okay, let me switch which screen I'm showing you. And I'm going to go into StatCrunch. Okay. So here I am, I'm in the StatCrunch platform. I've already imported my data previously. So when I log into StatCrunch, I'm just going to go right to my data and open up my data. Now, here we are going to be running a one sample t-test to test the hypothesis that the sample average score on the health score, the SF36, is significantly lower than 50. Stats, t-stat, one sample, and we have data. So for all of our tests, we are running them with the raw data. Here I am now in the one sample t-test platform. And what I am going to do is select the health score. And I am going to make sure I enter in my hypotheses. The null hypothesis predicts, right, that there's no difference between the population and the sample. The mean is going to be equal to 50. There's nothing interesting going on. But this alternative hypothesis is that the mean score is actually significantly lower than 50. Okay, so make sure you enter those parameters in. You're entering the null hypothesis and then the alternative hypothesis that the sample is significantly less healthy than 50. This test is going to allow us to compute those predictions against one another. And there's nothing else that you need to be clicking on here. Okay, all sorts of advanced and different options for, depending on what your goals are with your data, but we're just looking at the basic t-test to see what the result is. So I'm going to hit compute. And this is the data that I get. So we're looking to see whether the alternative hypothesis or the null hypothesis is supported. Here's our health score variable. The actual sample mean is 48.68, so it's really close to 50. It is a little bit lower, but the question is whether that's statistically significant or is it just due to chance and sampling error. Here's our standard error. We don't have to calculate it. The computer spits it out. We should have 24 degrees of freedom because there's 25 people in the study. N-1 gives us degrees of freedom. You're not getting a 24 here. You're doing something wrong. And here's our t-statistic. It's a negative 0.27 or a negative 0.266. Okay, where you round here is not going to change the fact that this is not significant. The p-value is less or is greater than 0.05, right? 0.39 is really large. When our p-value is greater than 0.05, we fail to reject the null hypothesis. We can't be confident that this sample mean is significantly lower than the population. So I do want to see you run the test. You'll then hit copy and you'll paste this exact table into your write-up. It's absolutely necessary that you show me that you've run the test and copy and pasted it. Because anybody can watch the video and just type up the results. I want to see that you ran the test just like I did. You got the data, you pulled it into Word, and then you're going to give us the string with the T terminology. T degrees of freedom equals what? What was the p-value, greater or less than 0.05? And then give us a few sentences about whether it's statistically significant. Is the sample more or less healthy than the population, or is there no significant difference? Okay, no measures of effect size in this one, so you will stop there after that's complete. And that's going to wrap up this video of me demoing the one sample t-test. Okay, any questions, put them up on the discussion board.